Okay, 4.6, arithmetic sequences here. An arithmetic sequence, we need to know some vocabulary in order to be able to do this. First, a sequence. A sequence is any order of numbers in a pattern. Okay, sequences have terms, and what we do is we label the sequence based on the term number. So, for instance, this would be the first term. First term is the 2. Second term. Third term is 12. Fourth term. Fifth term. And sixth term. And the little dots just mean it keeps going on forever. So our term is these are our terms right here. The position in those sequence is listed by that order. So the first term is 2. The position, 2 is in the first position. 7 is in the second position. 12 is in the third position. So we have these terms in specific positions. And what you'll see later is that allows us to make a table with this, okay? And in fact, I'll kind of mix that up right now here. We'd make a table. We'd say, well, we'd have 1, 2, 2, 7, 3, 12, 4, 17, 5, 22, and 6, 27. All right, and really when we're looking at this in terms of our table, we can say, well, this is kind of just like an XY table, except we're going to relabel X and Y here in a minute to mean something else. Okay, we're going to use different variables to represent X and Y, but really that's all we're doing there. Okay, it allows us to make a table using the position of our terms in a sequence. Now, an arithmetic sequence just means that you are adding to get the next term. So when I look at this pattern, I go, well, what would come next? Well, you'd have to figure out what's happening prior. So here I'm adding. It looks like I'm adding 5 here. I'm adding 5 here. Okay, so each time I'm adding 5. So that just means that my next term, if I wanted to keep doing that, would be 32. And then from there, add 5, I get 37. And from there, I mean, I could keep going, right? I could keep going on forever. So 42 and so on. Okay, so an arithmetic sequence just means you're adding to get the next term. Versus like a geometric sequence, we're multiplying. We'll study those later this year. Now, when I say adding, I also could mean subtracting. So like if you're subtracting a number, you're actually adding a negative, and we'll see that here in a minute. Now, the common difference is what you're adding. So the amount added to get the next term is called the common difference. So in this case, the common difference, or D, would be 5. Okay, that's what we're adding there. D would be 5. And that D is going to be a big deal here in a minute. Okay, moving on. All right, so graphing an arithmetic sequence. So graph an arithmetic sequence, and I kind of alluded to this here in a minute ago. You need to start by making a table. Okay, and the way we make our table, these are our Y values. So 4, 7, excuse me, I forgot the 1. So 1, 4, 7, and 10. So those are our Y values. Our X values are just the position. So first position is 1. Second position is 4. Third position is 7. Fourth position is 10. So this would be 1, 2, 3, 4. So that just means every time on top, the top of our table, or the X value of our table, is always going to go up by 1. The bottom is where we're looking for our common difference. Okay, so if I was actually asked to find the common difference here, the common difference would be 3, because I'm adding 3 every time. So D would equal 3. Okay, it's not asking that. It's just saying graph it. Okay, so really, I'm thinking this is X and this is Y. And like I said a while ago, these two things are going to eventually change to different variables, but they mean the same thing as X and Y. So look, I'm going 1, 1. and I'm going 2, 4, I'm going 3, 7, and I'm going 4, 10. You'll notice that when I look at it, it looks like I can connect these and draw a line. However, this is called discrete data. I'm not told that this data or that there's actual numbers that can be applied in between here. I don't know what 1.5 is, or if 1.5 exists. And in fact, when I'm dealing with a sequence, 1.5 does not exist. Therefore, since I can't actually go to 1.5 on the x-axis and like look up and see where it would hit the line or have a value for it, I can't actually draw a line connecting these dots. This is discrete data. So sequences provide discrete data. Okay, discrete meaning you don't connect the dots. Okay, you just have individual points. All right. So let's go ahead and take a look at something else here. All right. Whoa, hey, check that out. I actually have a table that I could have filled out. Man. All right. Well, let me show you using that table now how this goes. So 1, 2, 3, and 4. And 1, 4, 7, and 10. Man, that makes it look so much nicer than what I just had. But notice what I was calling X and Y. This was X. This was Y. We're now calling N. Well, what does N stand for? N just stands for the number, the position number it's in. So position 1, position 2, position 3, position 4. Okay? So rather than calling it X over here, we're going to say X is now called N. So that's the new letter we're using. And rather than calling it Y, we're now going to say it's A sub N. And I'll explain A sub N here in a minute. But that's our new variable there, A sub N. First, the sub just means the N's in the basement. It's below the little A there. And A sub N just works like this. If I said, okay, what is the fourth term? You would say, well, the fourth term is 10. Look, 4 is, when N is 4, A sub N is 10. So when I say the fourth term, that means A sub 4. I just put whatever I'm saying, the fourth term, the fourth position. N is 4, so I put 4 here and here. So A sub 4 is 10. The fourth term is 10. Okay? And that actually gives me an ordered pair. That ordered pair is 4, 10. Okay, now think back, X and Y. Try to relate it to that, X and Y. So X is 4, Y is 10. That's all it means. So what's kind of confusing about this, you see these new things, and that's why I tried to introduce it with X and Y. But really, they just mean the same thing as X and Y. We just call it N and A sub N. So if I say, what's the 100th term? I would say A sub 100. And we'd have to continue our pattern on for a long time. Or we'd have to know an equation, which we're going to know here in a few minutes. Okay, so let's go ahead and move on here. All right, let's take a look at some graphs real quick. First, does this represent an arithmetic sequence? Well, first, this graph. 1, 2, 1, 8, 2, 7, 3, 5, 4, 2. Well, you could first, if you want, you could just put it in a table. You could say, well, there's 1, 2, 3, and 4. And then I've got 8, 7, 5, and 2. Well, if it represents an arithmetic sequence, that means I have a common difference. I'm going up or down by the same amount. Well, in this case, I'm going down 1, I'm going down 3, or 2, excuse me. Fix that. And then I'm going down 3. So no common difference. And you'll notice they don't lie in a line either. That's the easy way to look at it. Hey, these aren't in a straight line. So no. Does this one? Well, looks like it does. It lies in a straight line. It appears that way. In fact, my slope, like if I went 1, 2, 3, 4, 5, and over 1, 1, 2, 3, 4, 5, and over 1, 1, 2, 3, 4, 5, and over 1. Yeah, it looks like it has the same slope even, and if I were to put it in a table, 1, 2, 3, and 4 for my N value, and A sub N, right, here's N, here's A sub N, is 18, 13, 8, and 3. Well, yeah, it looks like I'm going down 5. going down 5. Notice that 5 is my slope, right? We are counting 1, 2, 3, 4, okay. And notice whatever we go up or down by is also called our common difference. So this is an arithmetic sequence, and I've just kind of introduced a new piece. I just said our common difference is -5, and I also said we go down 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. That's also called our slope. So the common difference another name for common difference is slope. So another name for slope there, common difference is slope. So D is the same thing as our slope. All right. It's going to help us out, so I'm trying to leave all these little pebbles for you. Okay. Finding the nth term in an arithmetic sequence. And there's why we kind of built up to this here. Write an equation for the nth term of the arithmetic sequence. Well, in order to write an equation, first we know an arithmetic sequence is linear. And in order to write a linear equation, you have two options. You could use y equals mx plus b, or you can use point slope form, which is y minus y1 equals m times x minus x1. All right? It just depends what they give you. Well, when I look at this, I look at it and I go, well, I guess in table form, if I were to draw this out in a table and call this n and a sub n, my first term would be 3, my second term would be 8, my third term would be 13, and my fourth term would be 18. And in order to write either of these equations, I need to know the slope. So to write a linear equation, here I need to know m and b. To write one in point slope, I need to know m and a point, a coordinate, and x1, y1. Well, I've got to know m no matter what, and I've told you just a second ago that m is actually d, right? That's slope. Our slope is actually the common difference. So look, I'm going up 5, going up 5, going up 5, okay? So it looks like d equals 5, which means m equals 5. That's good to know, m equals 5. Now I look at this, do they give me the y-intercept? Well, the y-intercept was when x is 0, and they don't give me that. But they do give me a point. They give me a point, so I'm going to take the easiest point. You can use any of these points, so I'm going to use this one. I'm going to use the 1 and the 3. You can use any of them, but I'm going to use that one. So if I were to plug that in right here, y minus 3 equals m, or 5, times x minus x1, which is 1. That gives me an equation that I can solve. Okay? Now, the first thing I'd want to do, like if I was going to put this in slope-intercept form, I'd have to distribute and I'd have to move that 3 over. So let's say I move that 3 over. Y equals, I'd have to add 3 to both sides. I get 3 plus 5 times x minus 1. Okay? So for those of you like, whoa, 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 what did you just do? Look, I just added 3 to both sides. Okay? I can't add 3 to the 5 because it's attached to the 5x minus 1. Okay, and some of you are like, well, why did you write it so weird? Why didn't you put the 3 at the end? Okay, well, if you want me to, I can. But I'll show you why I didn't here in a minute. We could have it like that. Okay? Now, look, we've talked about x and y. We said x and y, we don't call x and y. In fact, look over here. X isn't called x. It's called n. So I'm going to change this x to an n. And y we don't call y. Y we call a sub n. So I'm going to change this y to a sub n. Now from there, remember what the 5 stands for. Okay, I'm trying to generalize this now. The 5 actually stands for d. So this was d. Okay, so I'm going to kind of write my general form here. A sub n equals 5 was d. we have n minus 1. Okay, and what was the 3? Well, the 3 actually was a sub 1, our first term. Okay, so the 3 represented a sub 1, the first term. Now, that is pretty darn close to what we call the explicit formula for finding an arithmetic sequence. Okay, notice I didn't change the 1 because the 1 is always 1. A sub 1 means our first term. So we keep 1 right there. The explicit formula to find any, the general form of this is actually a sub n is equal to a sub 1. So they put the a sub 1 out in front. When I say they, I mean the math people of the world. They put the 1 out in front, a sub 1 out in front, plus, and then n minus 1. N minus 1. Now some of you go, oh, where did the d go? Where did that d go? Well, they put the d in back, times d. Why? I quite honestly don't know why, and I haven't looked it up. I don't know if there's a good reason or not. So the d's back there, but it does the same thing. Like, look, if I wanted to write this in slope-intercept form, this equation, I could go, well, a sub n is equal to, I could distribute this, 5n minus 5 plus 3. And I know that that would actually be, I'm going to have to squeeze this in here, a sub n equals, we'll make that look like a subscript, 5n plus 2, right? Negative 5, oops, it wouldn't be plus 2, it would be minus 2. 5n minus 2. Negative 5 plus 3 is minus 2. So that's in slope-intercept form. That's in actually this form. Y equals 5n minus 2, but we don't call it y, we call it a sub n. So a sub n equals. Okay? But if we want to write it for any equation, we could just use that formula. We don't have to go through all this mess. Now, some people, like some students, would look at that and go, whoa, 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 why didn't we just use slope-intercept form? Well, we weren't given the y-intercept. And some of you go, hold on, isn't the y-intercept when x equals 0? When this equals 0? And I would say, yes, it is. What if that was 0? Well, you know the pattern. You just went backwards 1. Well, that means I just have to go backwards 5. What? Okay, there's the negative 2. So you could have just, I mean, that's a lot faster than doing all this. Now, you've got to know this formula. You're going to see it a lot, and you have to be able to write it out and read things from this formula. However, you have to also be able to look at it and go, well, I need to change this to slope-intercept form. And that's what we've done here. We've changed it to slope-intercept form. Or you can write it in slope-intercept form if you can figure out your pattern there. So let's try one more here, okay? First thing I'm going to do, we're going to write the sequence using this pattern. I am going to write out my formula. A sub n is equal to a sub 1 plus n minus 1 times d. Okay? First thing, find the difference. Looks like I'm going down 6, down 6, down 6. Okay. So d equals negative 6. All right. I also need to know a sub 1. Well, a sub 1 is just the first term. First term is negative 8. I have everything I need to write my equation. A sub n equals a sub 1, negative 8, plus n minus 1 times d, negative 6. Now, anytime I have a negative for a difference, I'm putting it in parentheses like that. Let's change that to slope-intercept form. A sub n is equal to negative 8 plus, well, I'm going to distribute this. Okay, so that would be negative 6 and positive, or negative 6n, excuse me, and then positive 6. I don't like having two symbols next to each other, so I'm just going to call that a big minus. I'm going to have negative 8 minus 6 n plus 6. putting the like terms together, -8 plus 6 is -2. So -6n and -2. And write that out in slope-intercept form. We put the -6 in first. There, we've got it. There's slope-intercept form, point-slope form. Was this one right here. Okay. Now, you could just leave it in this form if you want, unless I tell you otherwise. But it does say find a sub 50. And notice this previous one also said find a sub 50. And we didn't do that over here. Okay. So I'm going to use this equation right here, either this one or this one. Since I've already got in slope-intercept form, this is easier to use. I'm going to find a sub 50 using this equation. Okay, so I'm going to say, well, I want a sub 50 now. That means n equals 50. That's what a sub 50 means. Okay, so rather than having a sub n, I have a sub 50 equals -6 times 50 minus 2, which is -150 minus 2, or -152. That is a sub 50. That would be tough. I'd have to carry this out 50 times to figure it out. I mean, I could just keep writing the pattern. That'd be brutal. A sub 50 equals -152, and you should really write that as a sub 50 equals -152. All right. And so on that previous one, a sub 50 here, well, I've got my slope-intercept. Let's go ahead and figure it out. A sub 50 is equal to 5 times 50 minus 2, the 50th term. Okay, so that would be 250 minus 2, or 248. A sub 50 equals 248. Let's move that m and that 5 there. Okay. Let's kind of fix that up there. All right. Very good. Okay, and remember that problem at I think that's all I have for you, by the way. But remember that problem at the very beginning when I said, hey, what would we get if we had a sub 100? We could figure that out now if we knew our equation. Your equation is easy. Like if you don't want to write out that big long formula right here each time, you could carry your pattern backwards, right? I mean, 0 would be, well, we're increasing every time here by 3. So you could just go backwards 3. If I go backwards 3, that means I'm at -2. So my equation would be a sub n is equal to, well, the slope is 3x, or 3n, minus 2. Okay, and we could do the math from there. 3 times 100 minus 2 is 300 minus 2, or 298. Now, they didn't ask us to do that, so I'm erasing all this, because when I leave it on my notes, I don't want to ruin that for anyone there. Okay. If you want it on your notes, you get to write it in. All right? So there we go. I'm going to erase that as well. Okay. So I hope that helped out. Good lucky.